All right, let's do some social studies. All right, if you're out there and you're watching this, come to class live. Miss you. All right, so today we are going to talk about conservation and resources. PowerPoint. All right, so kind of the first thing, I'll just kind of run through some terms and we'll talk about some stuff. And then, per usual, we'll go over some questions at the end of class and go from there. So, conservation is simply, when we use the word conservation, we're talking about using natural resources carefully. So conservation is a little bit different than preservation, right? So when we use the word preservation, we're talking about totally preserving something and keeping it intact, right? Which, as it pertains to the environment, is different than conservation. Conservation says it's okay to use natural resources, but we need to be careful about it, and we need to have a long-term approach that doesn't, result in, negative lasting impacts, right? So conservation and conservationists, people who are practicing conservation and working on ways to do this, because it's difficult, right? Natural resources are something we can't live without at the present, right? We need a certain amount of resources. So it's really important that we try to use them in as careful a way as possible, and also a sustainable way, right? So you hear the term sustainability or sustainable use or all these things, right? And it still is, kind of a buzzword that you hear thrown around a lot. But what it really means is using something sustainably is using something in a way that doesn't exhaust them or lead to running out of a certain natural resource, right? For future generations. So when you're sustainably using something, you're using something in a capacity that that thing can be replenished, or you're conserving as much of that resource as possible for future people that might need it, right? Or that will need it, right? And so today's lesson kind of overlaps with some of the stuff I talk about in science, and so I'm not going to dive as deep into it here because it definitely falls more into science category than a social studies category, but we'll still talk about some stuff. So we talk about renewable versus non-renewable resources, and what does that mean? Right? That's pretty straightforward. If something is renewable, it means it can be reused over and over again, or it's something that will never run out, right? So renewable resources are resources that can either be sustained through replacement or things that just have an infinite capacity, right? We can use and use and use and use and it'll never run out. That's renewable resources. Non-renewable resources, exactly the opposite, right? Something that is renewable can be reused. That is not renewable can't be reused, right? So non-renewable resources are those things that once they're used, they're gone. And those typically, when we talk about non-renewable resources or non-renewable sources of energy, those are things like oil, gas, coal, right? Things that we burn to create energy, but then once they're burned up, we have to what? Go get more of it, right? The way gasoline works, unfortunately, right? When our car burns that gas to use for energy to move around, and our tank gets empty, it doesn't actually refill itself, right? We have to stop at a gas station and pump new gas in and then use that gas, right? Once it's burned, our tank gets to empty, it doesn't pop back to full on its own, right? It'd be nice if it did, but that's not the way it works, okay? So that's renewable versus non-renewable. A couple other things when we talk about the idea of scarcity. Scarcity is the threatening of resources, or the shortage of resources, right? If there is a scarcity of something, that means there is very little of it, and maybe to the point of there being none anymore, right? And then kind of under here, and these are kind of randomly thrown together terms, but just kind of all lumped off of the same lesson from the book. When we talk about scarcity as it pertains to plants and animals, right, we have endangered species laws that once a species, plant or animal, reaches a critical stage where there is not very many of them left, right, we have endangered species laws that help protect those threatened species so that hopefully they avoid going completely extinct, right? Pretty straightforward. Feel like we're familiar with that. So again, back to the non-renewable versus renewable sources of energy. And I'm not going to spend nearly as much time on this section as I do in science, but I'll break them down real quick, right? Non-renewable energy, again, fossil fuels, coal, oil, gas, right? Those are the big three when we talk about non-renewable energy. And then renewable energy on the other side of that would be nuclear energy, right? Which is controversial in a way, but it can be regenerated through the splitting of atoms, right? And we're not going to get into the science of that, but nuclear energy is oftentimes it's lumped on its own. It is renewable in a way, but it kind of gets pushed off in its own category. But when we talk about renewable energy sources, the big ones we talk about are solar, wind, and water, right? Solar energy meaning solar panels, wind energy, thinking, giant windmills, and water energy through dams, right? So we can harness the sun's power, like, using solar panels to charge batteries to then power whatever it is, right? The downside, solar energy is a very clean source of energy, but the downside is, you can't generate solar energy at night, or even if it's cloudy, or like in the winter. We have solar panels on our house, and in the summer, spring and summer months, it's great. We produce a lot of energy. But in the winter months, you have to account for the fact you're not going to produce much energy, because there's just less direct sunlight during the winter, and less of it, more darkness. Wind energy, again, non-polluting, very clean energy. But the problem with windmills is a lot of the components of them, once they are defunct, they're huge, right? And so they take up waste in landfills just like anything else, right? So water energy, same thing, very clean, non-polluting source of energy. Harnessing rivers' powers through dams. Damming rivers has its own set of issues, right? And mostly that revolve around disturbing the natural ecosystem of that river, right? You're really messing with nature, trying to harness rivers and regulate them to the extent that we do with damming, right? So my point isn't to say that any of those are bad. My point is to say that when we talk about sources of energy, it's a complicated conversation, because there are drawbacks to every form of energy, right? We're never going to have the perfect energy source that, avoids pollution, but also has there's no drawbacks to it, right? At least not that we can foresee, right? Maybe one day we will get there, but all of our current forms of energy have some amount of drawback, right? And the one kind of less common renewable energy source that I kind of skipped over there is geothermal energy. That's like naturally heated water in the earth. You can harness geothermal hot springs and turn that into usable energy, just like you can those other things. The geothermal energy, it makes up a very small portion of the renewable energy that our country or our world uses, because there are just not hot springs in every location, right? We happen to live somewhere where there are lots of hot springs near, in our region in general. But there are lots of regions around the country and around the world that don't have that. So it's a very limited source of renewable. Just to give you a quick idea, this is the breakdown as it existed in 2016, so 4 years old, but pretty recent in terms of United States energy consumption, right? So you can see a huge chunk of the pie, right? 37% petroleum, oil, 29% natural gas, 15% coal, 9% nuclear, right? So see how it's kind of lumped off on its own, and 10% is renewable energies, right? So 90% of the energy that we consume isn't renewable, right? Only 10% falls into this renewable energy spectrum. And within that, you can see we have geothermal, again, very small percentage, 2%. Even solar is a very small percentage, only 6% out of that 10% slice. So we're talking not much, right? We hear all this talk about solar, and it's becoming more common, but it still makes up a very small percentage of the United States energy. Wind, 21% of that 10%, right? Dams make up 24%. And this chunk here is what we'd refer to as biomass, which is basically the waste from various farms or different things that kind of, we can use waste or garbage to essentially, in some ways, right? We can use certain waste to produce fuels from that. Biofuels, some of it is purposefully harvested and grown vegetables that we can turn into oil or gas. And then wood is also lumped in there because wood is a form of biomass, because wood can be grown, harvested, used for energy, and then we can grow more wood. So again, I'm not going to go into in-depth on this because it just falls much more into this kind of science conversation. You see it more on the science test, but the bigger takeaway here is, non-renewable 90%, renewable 10%. We use a lot of non-renewable energy in our country. And then this is especially something that we'll talk about more in science, but just talking about what an ecosystem is. Right? An ecosystem is something where we talk about local environment made up of all living and non-living things. Right? And so in science, we have this step up from organism, population, community, ecosystem. Really, for social studies, we're just focused on the ecosystem, where it takes into account all living and non-living things in a particular region. Okay? So all the plants, all the animals, but also, the water, the atmosphere, mountains, hills, rocks, all of the non-living things impact ecosystems also, right? And even man-made things impact buildings, roads, and so on and so forth. Okay. So, but again, that's a conversation for science. So with that, let's jump to some practice questions. So if you came late and you're just kind of thrown into the middle here, that's fine, right? Let's look at some practice questions that deal with this idea of conservation and kind of responsible use of our energy. So I'm going to stop this share real quick and pull up some practice questions for the last bit of class here. Okay, so I think All right. So let's go through some of these and we'll see how many of them we get to. All right. So let's look at number one. Hopefully you can, I'll zoom in a little bit more. Number one just asks, what are renewable resources? So if you weren't here earlier, when we talked about non-renewable versus renewable, what is that difference? What are renewable energy? Or, renewable resources? So let's read our four choices and see if the answer just becomes obvious. A, materials that will never run out or can be replaced and used. B, materials that we do not use and use at a later date. C, materials that we use but cannot replace. Or D, an incentive to conserve materials. Okay, so if the right answer doesn't jump out, let's throw away some things. So renewable is just another way, or another is a synonym for reusable, right? So renewable resources are reusable resources that won't run out, right? And what does that match most closely with? It's not B, C, or D, materials that we do not use. So it's not that we don't use them, right? That would be complete preservation, where we're not using anything at all so that we can use it later, right? That's not what renewable resources are. C, materials that we use but cannot replace. That's defining what the opposite, non-renewable resources. Non-renewable resources are things that we use once and they're gone, like the gas in our car, right? Once our tank goes to empty, we got to get more. Right? And then D, an incentive to conserve materials, right? Renewable resources are a form of materials. It's not necessarily an incentive to conserve them. So A is the only one that makes any sense. Materials that will never run out or can be used, or sorry, can be replaced if used. All right, so let's look at number two. Number two says, which of the following is an example of the sustainable use of a resource? Right? And so just to recap what sustainable use is. Remember, sustainable use is using a resource carefully so that it can last a long time, preferably forever, right? Like take forests or wood, for example, right? If we're sustainably using wood, we would be using wood or cutting down wood at a rate equal to or less than the rate at which trees grow, right? If we're cutting down fewer trees than there are trees growing, then we're going to have more forests. If we're cutting down more trees than are growing, we're going to have less forests. Right? Sustainable use would say it's fine to cut down trees as long as we're cutting them down in a way that, or at a rate at which is going to allow more trees to grow than we're cutting down. So that was kind of a long-winded explanation. But let's look at which of these examples seem like sustainably using a resource. So we have A, burning fossil fuels, B, strip mining, C, overgrazing livestock, or D, rotating crops. So you might have to just kind of take a shot in the dark on this one, or you might be able to eliminate some. So just look at the wording of some of these. So overgrazing livestock, right? So overgrazing means what? Overgrazing means grazing too much. In other words, you have cows that are eating more grass than they should, right? Or are allowed to eat too much grass, right? Just the very word overgrazing implies the opposite of sustainable use, right? If we're overgrazing, then we're not sustaining that resource. We're burning it up too quickly. C doesn't make sense. And then I'd say A, burning fossil fuels. Right? Burning up fossil fuels isn't sustainable because our fossil fuel supply doesn't get replenished. So every time we use oil or gas or coal, we're cutting into our total amount, right? Which doesn't mean it doesn't mean we don't want to use any of it, or maybe we want to, but we at this point need to use it, right? So we can still use it carefully, but in this situation, it doesn't really make sense, right? Burning fossil fuels. If you really wanted to make an argument, you could put up a fight, but it doesn't fit as a great answer. So throw it out. And now we're left with B, strip mining, and D, rotating crops. Even if you don't have any idea what strip mining is or rotating crops is, I have a feeling if you were to guess which one is an example of sustainable use, you might guess rotating crops just by the way that it sounds. You'd be right. Strip mining just means like cutting away all of the earth and not just like looking for minerals in specific places, but just saying I'm gonna wipe away this whole hillside and hopefully there's some minerals in it. That's strip mining, not sustainable. So rotating crops means you grow one thing here the next year, and then you grow something else there. Then in field, you have a field, you grow corn, and then the next year you grow a different crop. And the next year you let it sit and have nothing, and then the next year you put another crop in. And the reason that's sustainable, and not that you even know this to answer the question, but if you grow the same thing on the same soil year after year after year after year, eventually you are taking out all of the nutrients from that soil because you're growing the same thing, and that same plant requires the same nutrients. And so it's sucking out all of the same nutrients year after year after year. Whereas if you plant different crops there and you have sporadic years where you don't grow anything there, you allow the soil to kind of retain its nutritional value for the plants, right? Okay, let's see here. Let's do a few more. I don't think we're going to do all of these, but let's see what else we want. Let's skip number 3. Let's do number 4. Number 4 says, in the United States, there is a disagreement about how to reduce dependence on foreign oil. Some favor exploiting domestic sources of oil, even if that means polluting the environment. Others prefer to concentrate on developing alternative renewable sources of energy. Which of the following best characterizes the underlying difference in points of view between pro-oil, pro-alternative energy factor? Okay, so here's a controversial topic, right? And this question is definitely written from a certain point of view, okay? Factor that in, right? Just go with it. You don't need to argue with it, right? These questions aren't meant to be arguments. They're just meant to be questions that you need to find the right answer to. So don't get caught up in that, right? But look at what it's saying, factor in the way it's explaining the evidence or the presenting the point, and then read the answer choices and pick the best one. So on one side we have, so what it's saying is, both sides of these arguments agree we want to reduce dependence on foreign oil. In other words, we don't want to be responsible for, we don't want to worry about other countries giving us oil. Right? So one side says, that's true, we don't want that. So let's use our own oil reserves instead. The other side of that says, yes, we agree, we don't want to be dependent on foreign oil. We also don't want to deplete all of our oil and pollute the environment. So let's put more energy into new alternative sources. So it's two sides to the same issue, right? Okay, so let's look at our answer choices. A, self-sufficiency versus interdependence. B, competition versus cooperation. C, short-term benefit versus long-term benefit. Or D, patriotism versus internationalism. So, the first two I'd probably get rid of. Patriotism versus internationalism. This is not an issue of patriotism, right? So, and and it's not an issue of internationalism, because both sides are saying they don't want to be dependent on foreign oil. Okay? So one isn't saying it's good to be dependent on foreign oil, and the other is saying no, it isn't. They're both saying no, it's not good, but we have different reasons or different answers to the question. Right? The question is, how do we reduce our dependence on foreign oil? That's the question. The two sides have two different answers to the same question. So it's not deep. The other one that I would say it isn't, and for similar reasons, is A, self-sufficiency versus interdependence. It isn't a matter of being self-sufficient or dependent on other countries, because, again, both sides of this agree they don't want to be dependent on other countries, and they want to be self-sufficient. So it's not A. A and D, both sides agree on. So it's either B or C. Competition versus cooperation, or short-term benefit versus long-term benefit. So make the best guess you can. What makes the most sense? B, to me, doesn't quite seem like it answers the question. Whereas C, whether you agree with it or not, seems to make the most sense. C is saying that the pro-oil, in other words, people saying we should use our nation's oil reserves so that we're less dependent on foreign oil, that's a short-term benefit. That solves the problem in the short term. But it doesn't factor in the idea that we might then run out, 100 years from now or whatever. That's more of a short-term. Whereas the pro-alternative energy faction is looking at things more from a long-term benefit, right? It's more of a pain in the butt now to deal with it. But hopefully, if we can develop more alternative sources of energy, in the future, we're going to be better off. So again, taking out whether or not you agree with it, C is the one that answers the question best. So then go with it. And then let's see. Let's just stop there for the day. I think we can go over a little bit more of this another time, but we're out of time and I don't want to run late. So with that, I will stop there for the day. We will spend the rest of the week kind of wrapping up this section, and then next week we'll kind of move on or move back to the beginning of social studies and kind of start fresh. So that's all I've got for today. Make sure you attend Martin's reading class if you need help with reading. That's at 12:15, and then I will be back for science at 1:15 if you need help with science. And again, reach out to us if you need help with something, if you need practice test codes, whatever it is, make sure you ask us. Okay? I know it's easy sometimes to not make that step, but if there are things that you feel like you need help with, just ask us, because if you don't know, we can't help. All right, so that's all I've got. I will see everyone back for science if you attend. Otherwise, I'll see you next time you're in social studies. Have a good one.